All right, so good to see everybody again. We got 2 weeks until our first major vacation of the year with Thanksgiving. So all we got to do is make it to next Friday. Just a few things to do in between now and then. So the plan for this week, we're going to talk about systems of equations. So hopefully that's a little bit more review material. Right now the plan is on Wednesday for you to work on the assignment. We'll talk about it on Thursday and then quiz on Friday. I don't know if we can make it through the lesson today, then we can move everything up, but we'll just kind of see how it works out. Okay, so let's get to it. Okay, systems of equations. Now, we're going to go ahead and start out with systems of linear equations. So typically your systems are going to be in standard form. Ax plus by is equal to c. You stack them on top of each other, and there's a lot of different strategies to use to solve a system. But let's talk about the solutions for just a second. If I were to take two straight lines and I plotted them at the same time in one coordinate plane, what are the three possibilities that I could end up with? If I take two straight lines and I put them in the same grid, they could what? They could be parallel. Okay. Now, the solution to a system, these are all the ordered pairs that make both equations true at the same time. Well, if they're parallel, they never interact. That's when a system is going to have no solution. They've got to intersect to have a solution. Okay, so that's one way. What's another way they could intersect? Oh, what's another thing they could do? In fact, I just said it. They can intersect. There you go. So if I graph two lines, they could intersect in one point. That means I have exactly one solution. Okay, one ordered pair x comma y is going to make both true at the same time. Now there's only one other option. If I graph two lines in the same plane, they could both be what? They could both be the same. So if I go ahead and graph a line, the other one could go right on top of it. This is where you have an infinite number of solutions. And this particular intersection has a name. Mathematically, we say they coincide. Like what you should do when it rains. Coincide. Coincide. I stand by that joke. Thank you. Thank you. Thank you. Okay. So the first part here, I'm not going to go ahead and read this to you word for word. I'm just going to go ahead and mention it. Really, the top two strategies that folks use when it comes to systems are going to be substitution, where I take one part of an equation and I substitute it into the other, allowing me to solve for one variable. Another is going to be elimination. This is where I either add or subtract the two equations together, eliminating one variable so that I can solve for the other one. Okay, so I'll let you go ahead and take a look at that when you get the opportunity. And then let's talk about no solutions. Now, one part of this I've got highlighted. It says a system of equations has no solutions when the two equations are the same except for their constants. Okay, and they give you an example here. So the coefficients of x, they have to be identical. So you notice how they're both threes. The coefficients of your y's are both identical. They're 2, but your constants have to be different. Okay, if this is what's happening to a system that's been given to you, that's no solution. Okay, so with that in mind, let's try our first example. Okay, so we have a negative ax minus 12y equals 15, and then 4x plus 3y equals negative 2. If the system has no solution, what's the value of a? Well, right now, I can't just go ahead and compare the two and go ahead and say, that a is going to be a negative 4, because that doesn't make sense, right? What would I have to do before I can actually equate them? Remember, what has to be the same between the two equations? It's a big word, started with a C. The coefficients, right? So with this variable here, I have no idea what it is. So I can't compare the x's, but look, I can compare the y values. Okay. So I want to go ahead and make sure that they're both the same. So all I have to do is change one of these equations. So between a negative 12 and a 3, I'm going to opt to change this negative 3 into a negative 12 by multiplying through as a negative 4. So up top, I have the negative ax minus 12y is equal to 15. Okay. Now, if I distribute, that would be a negative 16x minus 12y is equal to a positive 8. So I've set up the conditions where this should have no solution. If you take a look, I've made sure that the y coefficients are the same. The constants are what? Are they the same or different? They're different. That's what has to be happening here. So that means with this going on, those should now equal each other. So I should be able to say that negative a is equal to negative 16, but we can go ahead and divide or multiply through by negative 1. But the value of a that's going to make this no solution is 16. Okay. Questions? Okay. Well, now the next part here is going to talk about an infinite number of solutions. So systems of equations have infinitely many solutions when both equations are essentially the same. So what this means is the x coefficients have to be identical, the y coefficients are identical, and this is where the constants have to be the same as well. Okay, if they're both the exact same equation, you got yourself an infinite solution. Now, you want to be careful because sometimes at first glance, it might not look like it's a system with an infinite number of solutions. All right, take a look at this one around here. 6x plus 4y equals 10, and 3x plus 2y equals 5. What if I simply multiplied the bottom one by 2? Okay. So I've got 6x plus 4y equals 10 up top. But down below, 6x plus 4y is equal to 10. See, now they're identical. I know there's an infinite number of solutions. Okay, so let's try number 2. In the system of equations above, m and n are constants. If the system has infinitely many solutions, what is the value of m plus n? Okay, so m is one of my x coefficients, n is one of my y coefficients. So where should I focus? How should I try to go ahead and ensure that both of these equations are going to be the same? Because right now I can't say that 3 equals n, for example. Any ideas? Okay. Well, what do we know about the constants in this case? There you go. The constants have to be the same. So why don't I go ahead and take the top one and let's multiply it by 4. Okay, so that's going to give me a 12x minus 20y is equal to a 32. And then down below, I've got mx minus ny is equal to 32. Now that I've ensured that both of those constants are the same, I can go ahead and pair up the rest of them. What should m equal? Yeah. Remember, if they're the same, that means this coefficient of x has got to equal this coefficient of x. So m's got to be 12. Okay, what about n? N's got to be 20. And think about what we did a moment ago. Negative n would equal negative 20. So yeah, n equals 20. So what is m plus n? 32. Here we go. How we doing? And then we got everybody's favorite, word problems. Okay, so let's try this one. A group of 30 students ordered lunch from a restaurant. Each student gets either a burger or a salad. The price of a burger is $5 and the price of a salad is $6. If the group spent a total of $162, how many students ordered burgers? Now, with the word problem, I've always taught this the same way. Always identify the variables you're going to use. Okay, we're talking about burgers and what? Salads. So let's say that X is going to be the number of burgers that were bought, and Y is going to be the number of salads that were bought. Okay. Well, how many burgers and salads are there total? 30, because every student ate, right? So that would be one of my equations. So the number of burgers X plus the number of salads Y is equal to 30. So let us continue. But you got that one. We're talking about a salad. Let us continue. Come on, working hard up here. Okay. All right. So the other equation, we're going to incorporate the money. How much is a burger? Okay, so that would be $5 times the number of burgers sold, plus what? 6Y, $6 times the number of salads sold, and their grand total was $162. Okay, now what we're trying to find is the number of burgers. So what I would do, I would personally prefer to use elimination. Substitution is a great method and it's always going to work, but there might be times where you have to go fractional. And while I know a lot of students love fractions, probably best to avoid it. So let's say I want to eliminate the y's. Okay. I can go ahead and multiply the top equation by either 6 or negative 6. Excuse me. Now, if I go ahead and make sure they're identical, then I can subtract the two equations. If I make them opposites, one positive, one negative, well, then I can just add them together. So it really doesn't matter. What would you like me to do? 6 or negative 6? Leah, what do you think? 6. Okay, so let's see here. That's going to give me 6x plus 6y is equal to, I need a 30 times 6. 180. And then 5x plus 6y is equal to 162. So because we made sure that the y's have the same coefficient, we're going to subtract here. And see, this works out nicely. 6x minus 5x, there's the x, the number of burgers that we're trying to solve for. What's a 180 minus 162? 18. So there were 18 burgers ordered on the trip. Okay. How we doing? Okay. Now, while I say that, in a system like that, elimination is probably the better way to go. For this system, this is a system of nonlinear equations. Okay. So substitution is going to be the way to go on this one. In fact, if y plus 3x is equal to 0, would everybody agree that y is equal to a negative 3x? All I did was subtract the 3x over. Now that you've got one equation solved for a variable, this is when you substitute. If I know that y equals negative 3x, plug it in the other equation, so you've got the one variable to solve for. So x squared plus 2y squared, so that becomes 2 times a negative 3x squared equals 76. Is everybody okay? All right, let's go ahead and start running through and see what we got here. So what is a negative 3x quantity squared? So that would be 9x squared. So then we have x squared plus 18x squared. 9x squared times 2 is equal to 76. So it looks like we're going to get 19x squared is equal to 76. So somebody help me out. I need a 76 divided by 19. It is 4. Okay. How do I get rid of a square? Square root. Here we go. Now, here's the thing, though, and a lot of students forget about this. We're solving an equation. If you have to take an even root, what am I going to put in front of my answer? There's two symbols, plus and minus. Okay, if you're solving an equation and you're forced to take an even root, you want to put plus minus in front of your answer there. Okay. So we've got two possibilities here. So because I got two values of x, that means that these would intersect in 2 points. One where x is a positive 2, the other where x is a negative 2. Well, what's nice about this, we already have y equals negative 3x, right? So let's plug this in. What's a negative 3 times 2? So that's a negative 6. Negative 3 times negative 2, that's a positive 6. So how do I know which y is my answer? There you go. See, it tells you in the instructions, y is greater than 0. It wants the positive. So that means 6 is my answer. Okay, how we doing? Anybody having a hard time? Okay, cool. All right. Well, let's try this one. So we've got this definitely a nonlinear system of equations. If xy is a solution to the equation above, what is a possible value for y? Okay. Now, a lot of times with these PSAT problems, they're going to be created in a specific way. It's almost like they're giving you a hint. Okay. So remember what I said a moment ago, with a nonlinear system, substitution is probably the better way to go. So let's go ahead and take a look at xy plus 2y equals 2. So xy plus 2y equals 2. That's a 2 right there. Now, I want to go ahead and solve this for y. Okay. But I don't have like terms because I don't know what x is. So what if I treated it like this? What does GCF stand for? Greatest common factor. So what if I just divided that y out? Well, that would leave me y times x plus 2 equals 2, right? Now, how would I solve for y? Okay, let's divide by x plus 2. So here's what we're getting. We're getting that y equals 2 over x plus 2. You notice anything? How close is that to what they have in the second equation? We have 2 over x plus 2. They have 1 over x plus 2. That is not a coincidence. They do this a lot on the PSAT and the SAT, where they're hoping you're going to see some little trick. Okay? Why don't we go ahead and make sure that 2 over x plus 2 equals what they have here? Okay. Well, let me go ahead and do this. What if I put this y over 1? What if I multiplied through by a half? Because whatever I do to one side, I got to do to the other, right? Well, these 2's are going to cancel. What does this expression now equal? What's going to be left here when those 2's cancel? 1. See, all I had to do was a little bit of algebra, and now it matches up what we have in the other equation. And don't get me wrong, you can go ahead and square this and solve it like a rational like we did prior, but this is going to save you so much time. I now know that this fraction equals y over 2. So let's use that to my advantage. So I'm going to say y over 2 squared plus y over 2 minus 6 is equal to 0. I mean, that just looks a little better than that big fraction we had. So what do I get if I square y over 2? Y squared over 4 plus y over 2 minus 6 is equal to 0. Now, I know it's going to break your heart to go ahead and do this, but you probably want to go ahead and get rid of the fractions. Okay. What should I multiply by that will remove both at the same time? Okay, what's one number I can multiply by that will remove both fractions? Well, see, 2 would cancel with this 2, but 2 would cancel with that 4 and leave me a what? So I'd still have a fraction there. So what's a common multiple between 4 and 2? What's the first number that both 2 and 4 would evenly divide into? 8, that would work, but 4 would work as well. Okay. So let's see here. Those 4s would cancel. There's your y squared. Plus, now I need 4 times 1/2 y. Well, 4 halves would give me 2 minus 24 is equal to 0. See, that's a much simpler equation that we can solve now. Okay. All right. And this is a simple trinomial too. What two numbers are multiplied to give me a negative 24, but add to give me a positive 2? Okay, 6 and 4. But which one's which? Y minus 4, y plus 6. Okay. Now that's great. How does that help me find my values of y, though? What did we do in a previous lesson? We did something with those groups. We set them equal to 0. So if y minus 4 is equal to 0, well, y equals 4. If y plus 6 is equal to 0, then y equals what? Negative 6. Now, we found two solutions. Let's go back up and see what they're wanting. It is what is a possible value for the absolute value of y? Well, we solved for y. So what's the absolute value of 4? 4. What's the absolute value of a negative 6? 6. Either of those solutions would work. Okay. It is very possible that you could have multiple answers, but you only need to put one. Okay. All right. How are we doing? Any questions? Am I having a hard time? Nice. Okay. Well, example 6. If xy equals 8, xz equals 5, and yz equals 10, what's a possible positive value for xyz? So I know what you're thinking after all this time. You're like, oh, Mr. West, I got this. I can do it. Okay. So let me give you about a minute. Let's see if you can find the solution here. Set a minute on the timer. Here we go. So I'm currently working on number 6. Let's see if we can get that answer. Okay. So that is 1 minute. Anybody think they know what the answer is? Okay. Or how would I at least approach the problem then if we don't know the solution? Think about it in a situation like this. They're giving me 3 different products. We know x times y is 8, x times z is 5, y times z is 10. They're wanting me to find what? X times y times z. Okay. Well, if I have any hope of getting x, y, z, why don't I go ahead and take what I have and go ahead and multiply those together? Like xy times xz times yz. Can anybody tell me what that's going to give me? Remember our exponent rules. What's x times x? X squared. Okay. Y times y? Y squared. And z times z? Okay. Now, Based on what we did here, remember xy was 8, xz was 5, yz was 10. So I'm looking for an 8 times 5 times 10. 400. So I know that this equals 400. Now I've got x squared, y squared, z squared. They want x, y, z. What would I do? Square root. So the square root of that product will give me x, y, z. Now it wants the positive value. What's the square root of 400? 20. There you go. Was anybody on the right track? No? That's the nice thing about these problems. You know, if you have an idea, just try it and see what happens. You never know. Okay. All right. The one thing you don't want to do is leave it blank, whether it's multiple choice or the fill in the blank, because what's the penalty if you get a question wrong? There is no penalty. There used to be a point deduction, but there's not anymore. In fact, this new PSAT is very, very different from when I took it. But you're probably saying, oh, that wasn't too long ago, Mr. West. You're a youngin'. Okay. This next part here talks about the graphs. Basically how we started the lesson. It talks about intersecting lines will have one solution. Then it goes on parallel lines will have no solution. And lines that are exactly the same, they coincide, there's an infinite number. So again, not going to go ahead and read that verbatim. I'll let you read that when you have the opportunity. Okay, but we're on number 7. So it says in the xy plane, the lines y equals 3x minus 5 and y equals negative 2x plus 10, they intersect in this point hk. What's the value of k? All right, so ideas. Maybe if I stacked them, it'd be a little easier to see. So y equals 3x minus 5. And we also have y is equal to a negative 2x plus 10. Well, do you notice anything about the two equations that they have in common? What do they both equal? Yeah. They both equal y, right? So if they both equal the same variable, what should I be able to do? Equal them to each other, yeah. So I can say 3x minus 5 should equal a negative 2x plus 10. And see, now you just solve a normal everyday equation. Okay. What term would you like me to move first? Bless you. Okay, the 3 or the negative 2? Okay, so let's add that 2x over. I'll go ahead and write it out this term. So plus 2x plus 2x. Now at the same time, why don't we go ahead and add that 5 over. Okay. So opposites are going to cancel. It looks like 5x is equal to what? 15. So that tells me that x is equal to 3. Now here's the thing. They're going to do this, and I don't know the reasoning behind this. You'll notice how they're using x and y in the equations, but they go ahead and say the answer is hk. Well, that's no different than just a normal everyday point xy. So if they're wanting k, what value are they really wanting? The y value. Okay. So we know x is 3, and it doesn't matter which one I plug back into. Okay. Which one would you like me to plug back into? Nadia, do you like the top one or the bottom? The bottom. So y equals, so negative 2x becomes negative 2 times 3 plus 10, and a negative 6 plus 10, that'll give me a what? 4. So that's what I'm looking for. Okay. Making good progress. Number 8. Okay, the system of equations above is graphed in the xy plane. If the ordered pair xy represents an intersection point of the graphs of the two equations, what is one possible value of y? Now, these aren't linear. One of them is, but it's a system of nonlinear equations. But couldn't I just do what we did in number 7? Both of them equal what? y. Yeah. So I could just say they equal each other, right? I could just say that x plus 1 is equal to x squared minus 5x plus 6. Now we just need to go ahead and combine my like terms. Let's see here. So the x squared is not combining with anything. What's a negative 5x minus x? Negative 6x. And then I need a 6 minus 1. Plus 5. All right. And it's a simple trinomial, so let's break it apart. In fact, this one's even nicer to me because 5 is prime. The only two factors are 1 and 5 itself. Now, they've got to multiply to give me a positive 5, but add to give me a negative 6. So what are my signs here going to be? They both have to be negative. Minus and minus. Okay. How does that help me solve, though? What have we seen numerous times? Take the groups and what? Set them equal to 0. So if x minus 1 equals 0, x equals 1 is my first answer here. If x minus 5 is equal to 0, then x equals 5. Now be careful, they're wanting what? They want y. So because I got two values, that tells me that these are intersecting in 2 points. And it doesn't matter which one as long as I go ahead and find one of them. So let's say I go ahead and plug the 1 in here. So 1 plus 1 would give me 2. The 5 plus 1 would give me 6. So it doesn't matter which one, either of those would be considered correct. How are we doing? Anybody having a hard time? Like stroll down memory lane, algebra 2? Fun? Okay. Okay, example 9. So we have, this is already graphed for us, y squared equals x plus 3, and then y equals the absolute value of x. So a system of 2 equations, and their graphs in the xy plane are shown above. How many solutions does the system have? Now remember, I've talked about this verbally before. The number of solutions is based on how many times the graphs what? Intersect. How many times do these two graphs touch? Twice. So there'd be a solution here and a solution here. So there we go. Oh, and I thought for some reason we had 13 problems in this one. That was the end. Oh, now everybody's going to be disappointed. Okay. All right. So the good news is that means we should basically have ourselves a free Friday. When we come in this week, I'll go ahead and give you the assignment tomorrow to go ahead and take a look at. We'll talk about that on Wednesday. We'll quiz on Thursday. And then we'll just go ahead and SEL on Friday, kind of kick back. Okay. And we'll have 1 week left to Thanksgiving. We get a 9-day vacation. All right. Well, if you'll go ahead and put the calculators back up to the front, I'll go ahead and start shutting everything down.